Hi, welcome to these notes on Math 8 Unit 6 Associations of Data. So let's go ahead and get started. So our first learning target is we're going to be able to construct and interpret scatter plots for bivariate measurements, to investigate patterns of association between two quantities. We will investigate and describe patterns such as clustering, outliers, positive or negative association, linear association, and nonlinear association. Our next goal is to model the relationship between bivariate quantity datas to informally fit a straight line for a scatter plot that suggests a linear association, and to informally assess the model fit by judging the closeness of the data points on the line. So a lot of that said, basically we're going to construct scatter plots. We're going to investigate what they mean. We're going to make straight lines that go through them to predict what's happening. So now let's go ahead and move on to the actual activity. So let's take a look at this first part. So applying associations of data. Warm up. Pandas. The giant panda lives in a zoo. So let's look at this graph that we have over here to the right. So looking at that graph, what can we say about this point right here? 36 what and 82 what? So if we look down at the graph, this is 36 age in months and 82 weight in kilograms. So we know that a 36-month panda weighs 82 kilograms. 36-month-old panda weighs 82 kilograms. I'm going to move that word old a little spaced out. Okay. Then it says there is another panda, B, that is 6 years old and weighs 100 kilograms. So then we're going to put that on the graph. So 6 years old and 100 kilograms. Well, it looks like they're doing it in months. So we need to do 6 times 12, which is 72 months. So we need to find the ordered pair, 72 months and 100 kilograms. And we're going to put that on the graph. So 72 months is right here. And then we're going to go up until we hit 100. So go across right here and then put a dot. And then your ordered pair, 72, 100. And that's going to be Panda B. And if we want to label this one, we can label it as Panda A. All right, so now we have two pandas on our chart. Panda C is at the point 1262. So Panda C is 1262. Then it says, if there were Panda D, who's 24 months in age, what would we predict? So let's go ahead and put Panda C on the graph. So that's 1262. So 12 months and about 62 pounds will be about right here. So that's Panda C. So 12, 62. If we want to predict where Panda D would lie, so D is 24 months old. So that's going to be about right here. Where should we stop our line? Probably about right here. Because it looks like every month or so that these pandas are growing kilogram by kilogram. So we're going to make that prediction line. So it's almost like we were to draw a line through here. So this prediction point right here can be where D is located. So that looks like probably about 70 kilograms. So our prediction would be about 70 kilograms. And we could say on the graph. So let's recap what we did. The first thing we did was we interpreted Panda A. Then we plotted Panda B. C we put on the graph to help us determine where should Panda D fall. And we put Panda D where the yellow point is, around 24 months and 70 kilograms. All right. That's activity 1. So now let's move on to activity 2. So activity 2 says the weight versus fuel efficiency. The table in the scatter plot shows weight and fuel efficiency of 18 cars. Typically, the heavier your car, the less fuel efficient your car is. If you look at this graph, it looks like it's going in this downward trend where the heavier your car, so here's your weight, the less fuel mileage that you get. So you have to fill up your tank more often. So what we're going to do is we're going to fill in some information. Number 1 says, which point in the scatter plot represents car L in its measurements? So we're going to find L in the chart. So L is located right here. So we're looking for the point 1,663 and 19. So 1,663 and 19. 19 is probably about right here. And then that one's right here. So let's circle that point. All right, so that's going to be L. So we can say on the graph. All right, number 2, what is the fuel efficiency of the car with the greatest weight? So let's look for the car with the greatest weight in the graph and the chart. So for me, I think it's this guy right here. So that's our greatest weight. And let's see which one that is in the table. So look for the one with the greatest weight. So we're looking in this column right here that I circled in blue. So look for the biggest number you can. And it looks like it is G right here. So G is the car that has the greatest weight. And that order pair is 2,384 kilograms. And that only gets us 16 miles to the gallon. All right. Number 3, what is the weight of the car with the greatest fuel efficiency? So this is the one that's going to give us the most miles per hour. So let's look up here at the very top. This is giving us the most miles per hour, this group up here. The one with the highest is this dot that I'm going to highlight right now. And that's sitting at 30 miles per gallon, and that is a car that weighs 1,250. So let's find one in the graph that says that, or in the chart that says that. So we're looking for 30 miles to the gallon, and we're looking for about 1,250. So it might be this one. Looking for another 30. And that's it. So it must be that 1,234. So Q. And that is 1,234. And that's 30 miles to the gallon. So what does it weigh? It weighs 1,234 kilograms. And for number 2, I forgot to tell you that the fuel efficiency is 16 miles per gallon. That's the direct answer for number 2. All right, number 4, car S weighs 1,912 kilograms and gets 16 miles per gallon. On the scatter plot, plot a point that represents car S. So car S is not actually on the chart, so we're going to add it now ourselves. So we're looking for 1,912 and 16 miles per gallon. So I know that it's going to be somewhere on this line is 16 miles per gallon, and it is 1,912, which is about right here. So I'm going to say that this green dot that I'm putting on the chart, that's going to be S right there. So if we want to add it to our table, we can. 1,912 and 16, and then there's our table with that added order pair. Okay. And we can, if we want to put it attached here, we can as well. All right. Cars N and O shown on the scatter plot are made by the same company. Compare their weights and their fuel efficiency. Does anything surprise you about these cars? So we're looking at N and O. So let's look at N and O. I'm going to highlight them on the table in red. Let me do a different color. Let me do purple. N and O. And then I'm going to find them on the graph as well. So N is 1,432 and 25. So that one looks like that purple one there. And then O is 1,987 and 18. So that one all the way down there. So does anything surprise us about these two cars? Well, I mean, they kind of they follow the pattern. The lighter the car, the more fuel efficient. So for me, nothing surprises. Because the lighter car is better gas mileage or has better gas mileage. Okay. A different company makes car F and G. Compared their weights and fuel efficiencies. Does anything surprise us? So this time we're looking at F and G. So I'm going to grab my highlighter. I'll do a different color this time. Let's do orange. So F and G. So those do surprise me. And here's the reason why. They weigh almost 400 pounds or 400 kilograms different, but yet they get the same gas mileage. So G, we already put down here. So they make not very fuel efficient cars. And then there was another one that also was at 16. So that needs to be down here. So I don't know if you can see my orange. But right here and right here, those two orange dots. So F and G, like that is surprising. So their weights are very different, but they have the same fuel efficiency. So they have a 400 kilogram difference, but yet they get the same fuel efficiency. The same MPGs. So that's not very good. So you don't want a car that's super light, but yet it still gets bad gas mileage. All right, so let's recap that one. We were able to look at a graph. We were able to look at a table, compare the two ordered pairs that represent it. We were able to decipher where a new order pair should go. Then we were able to decide, does the point make sense or does it not make sense? All right, next activity. Activity number 2, predictions. Here's a scatter plot that shows the weights and fuel efficiencies of 20 different types of cars. So this is what we were just doing. So all of these are on the chart from before. If a car weighs 1,750 kilograms, would you expect the fuel efficiency to be closer to 22 or 28 miles per gallon? So we're looking for 1750. So find 1750 and go up. So about where should it land? Should land kind of in this section. So if we were to draw, it's called like a prediction line. They also call it a trend line. So if we were to draw that, about where should we land? We should land about right here. If we go across, it looks like we're sitting really close to 21. So I'd say 22 is going to be our best bet. So what's our explanation? We drew a trend line and 22 miles per gallon was the better predictor. All right. So now let's go to number 2. Stephanie was given a scatter plot that shows the heights and weights of 25 dogs. So this is a very long paragraph, but we're going to read it together. So 25 dogs. The scatter plot has a graph of linear function, which is a model for the relationship between dogs' height and their weight. And this is called the line of best fit. So that trend line that I just drew in red, so that's another word that we're going to use for this. The line of best fit is also called a trend line. She can see that the model does a good job of predicting, so that's what we're using it for, the weight given the height of some dogs. These correspond to points on or near the line. She notices the model doesn't do a very good job of predicting the weight given the height for the dogs whose points are far from the line. So what she's saying is that the points that are super duper close, so like all of these dots right here, like it does a very good job predicting those dogs. But then let's look at these dots here. Like that doesn't really fit the rest of the data. So those are what we can also call outliers. And we're going to work with those in just a minute. So let's answer these questions here. If a dog is 27 inches tall, what would Stephanie predict using the line of best fit? So we're not going to find the dog that actually is 27 inches tall. We're going to use the line. So we're going to go 27. We're going to go all the way up till we hit the line. And so what we should predict is that a dog should weigh about 80 pounds. What we're noticing, though, is there are two dogs that are 27 inches in height. If you look here and here, so this one and this one, those are 27 inches, but they are not on the line. So we're using the line to predict this. All right. B, compare that to the weight and height of the two dogs who are 27 inches. So we have a dog who's 27 inches, and he is about, I'd say, 76 pounds. But then we also have a dog who's 27 inches tall, but then he's weighing almost 112 pounds. So we're going to round a little bit down and do like 108. Those are very significant. So this one, the first dog, is very close to the predicting line, but this one is very far away. So probably what's happening is that this dog right here, that's super far away, he's probably overweight. So he's too big for how tall he is. All right, what if a dog is 30 inches tall? What could we predict? So what we're going to do is we're going to take our trend line and we're going to continue drawing it. So I want you to take your pencil and I want you to finish drawing the trend line off the chart. Just draw it all the way off the chart as straight as you can. Then we're going to use that to predict. So draw from 30 straight up, put a dot, then come all the way over. And that's about 96. So we'll probably go like 93 or 94. So using the trend line, about 93 pounds if they are 30 inches tall. All right, so what we're going to do is we're going to stop here, and then tomorrow you'll finish up these notes with me on activity number 3, the glossary, and then some practice problems. I hope that this was a nice introduction to scatter plots. We've done a lot today. Looking through all of this, we predicted the panda's weight. We then looked at car fuel efficiency and decided which plots were represented by which points. And then we also did some predictions on some dog weights and looking at those graphs and using a trend line. So you guys have done a great job. Thank you so much. And then tomorrow's video will be the remainder of these notes. So please don't lose these notes. Save them for tomorrow. All right. Have a great day. Thank you.